Assalamualaikum and salam sejahtera. My name is Nick Ahmad Khan, teaching at SMK Datuk Perdana. I'm going to discuss the question number 20 of sample SPM paper for semester 1. Normally, question number 20 is located for chapter 9, Kinetic Theory of Gases, chapter 10 for Thermodynamics of Gases, and chapter 11 for heat transfer. Okay. Specifically, I will discuss question number 20 from the chapter 11 of heat transfer. Under chapter 11, there are 4 subtopics which students should be able to understand the contents mentioned. The 4 subtopics are heat conduction, heat convection, heat radiation, and global warming. And for this session, we are going to concentrate the subtopic of heat radiation. Chapter 11, heat transfer subtopic 11.3 under radiation. Students should be able to describe heat transfer by radiation, use Stephen Boltzmann equation P equal to dq over dt equal to E sigma A T to the power of 4, and define a black body. What is heat radiation? Hi students, before we solve the selected question, actually how the heat radiation occurs. Actually, heat radiation is a direct result of the random movement of atoms and molecules in matter. Heat energy is produced due to collision and friction during matter movement. At stage 2, the pool of heat energy is created and the temperature is slowly increasing above the absolute 0 point. At stage 3, since these atoms and molecules are composed of charged particles, proton and electron, their movement helped by interior heat produces in the emission of electromagnetic radiation, which carries the energy away from the surface. Now, we are going to answer the question number 20. Explain what is meant by a black body. Now, look at the question number 20A. Explain what is meant by black body. 2 marks. Meaning that at least we should write down 2 points in order to obtain the full marks. Before we answer the question, let's see what is the main idea behind the term of black body. Look at the diagram. I hope it will help you to understand how the black body occurs. A black body is defined as a body that absorbs all electromagnetic radiations of any wavelength falling on it. Since it neither reflects nor transmits any radiation, it appears black whatever the color of the incident radiation may be. So, the answer for the first question, we can say that a perfectly black body is a body that absorbs totally all the electromagnetic radiation of any wavelength which fall on it. Since it neither reflects nor transmits any radiations, it appears black whatever the color of incident radiation may be. Watch out the keywords such as absorbs all radiations, no reflection, no transmission, appears black. before we move to the next question, I have two simple extra questions regarding the black body. Look at the first one. The question is it a body reflect electromagnetic radiation? Could be a black body, such as a highly polished silver surface, for example, chrome metal, strophy, etc. And the second question is it a body transmit electromagnetic radiation? Could be a black body, such as a glass, transparent objects, mirror. Oh yeah, mirror also is a good reflector. So what is the answer? The answers are no. Why? Because the object is neither reflects nor transmit any radiation. That's why it appears black, whatever the color of the incident radiation may be. That's why it appears black, whatever the color of incident radiation fall on it. Actually, the more black in color the body is, the higher the thermal energy kept inside the body. Okay, now we look at question number 20b. The sun with a surface temperature of 6,000 Kelvin may be assumed to be a radiative equilibrium with the Earth. The radius of the sun R equal to 7.0 times 10 to the power of 8 meter, and the Earth is at a distance R equal to 1.5 times 10 to the power 12 meter from the sun. Okay, student, please pay your attention. The first step is pick out all the information given in the question. Better if you can sketch the question into a simple diagram and label them accordingly, like I did. See at my diagram. The question is, calculate the rate of thermal energy radiated from the sun's surface per second. Okay, be cool, student. The second step is recognize the main question. Calculate the rate of thermal energy. Underline it. Identify the related formula. For example, the word rate. Surely the physical quantity is divided by time. Thermal energy, one of the various energies exists in the world. Therefore, the combination of both these physical quantities produce energy per unit time, E per T, equal to Q per T, equal to power. The third step is try to recall the related formula involved in this subtopic. The power of electromagnetic radiation is equal to the rate of heat radiation energy change. Therefore, P equal to E times sigma times A times T to the power of 4. And E stands for emissivity of material, sigma stands for Stephen's constant, A stands for surface area of the point energy, and T stands for surface temperature. Therefore, P equal to, I repeat, P equal to E times sigma times 4 pi r squared T to the power of 4. And we substitute all the information given in the equation, and we come out with 4.52 times 10 to the power of 26 watt. Don't forget to write down the unit. Otherwise, 1 mark will be deducted from your marks. Be careful with small number and big number during calculation. High experience using calculator is greatly helpful to solve calculation in seconds. Now, we turn to next question, B2. Question number 20, B2, calculate the intensity of radiation. from the sun on the Earth's surface. 3 marks. Underline the main word, intensity. What is an intensity? The intensity is the rate of energy transferred per unit area in the direction of wave propagation. Okay, it mentions the rate of energy transferred. It is equal to the power. Therefore, intensity means power per unit area perpendicular to the direction of wave propagation, or I is equal to P per A. Okay, look at the diagram. Study the diagram carefully. Actually, we are looking at the intensity of the heat radiation at the surface of the Earth, specifically at the yellowish area. So, intensity I is equal to the power per unit spherical surface area with the perpendicular distance r from the point source. Then, I is equal to power per 4 pi r square. Okay. Be careful during the substitute of the magnitude given into the formula. So, we come out with 4.52 times 10 to the power of 26 divided by 4 pi times 1.5 to the power 10 of times 10 to the power of 11 square. Then the answer is 1.6 times 10 to the power of 3 watt per meter square. Please, again, don't forget the unit. Now we turn to question B3. Calculate the equilibrium temperature of the Earth. What is mean of the equilibrium temperature of the Earth? 4 marks. This is thermal equilibrium situation where the Earth's temperature is equal to the temperature of its surrounding. In other words, if we assume that the Earth is a perfect black body, at the equilibrium temperature, surely the total power of heat radiation absorbed by the Earth is equal to the total power radiated by the Earth. Meaning that power absorbed is equal to the intensity of radiation received times the cross-sectional area of the receiver. On the other hand, the radiated power is equal to E, emissivity of a material times Stephen constant times surface area of the radiator times the surface temperature of the radiator to the power of 4. So you can see the equation I write down. Be careful. Pi r square represents cross-sectional area of the receiver, and 4 pi r square represents radiator of the surface area. Small r represent the same radius. For this case, receiver and radiator are the same object. That is why we cancel off pi r square for both sides. Now, d to the power of 4 is equal to intensity per 4 sigma. Substitute all the magnitudes given. We come out with the answer of T is equal to 290 Kelvin. And the last question, C. Next question is, suggest are the assumptions made in order to obtain the solution. In order to obtain the closed answer, we should consider that both the Sun and Earth are perfectly two black body radiator or absorber. And the second one is the Earth does not receive other heat sources, such as heat from its interior or other planets or etc. And lastly, give one reason, okay, why the temperature of the Earth is lighter, is higher, or lighter than the equilibrium temperature calculated above. All this is due to greenhouse effect. What is greenhouse effect? The greenhouse effect is a process by which thermal radiation from the Earth's surface is absorbed by atmospheric gases which act black body and re-radiated back to the Earth's surface. This process will increase the temperature of the Earth's surface. Lastly, thanks for watching me. See you again next session. Assalamualaikum warahmatullahi wabarakatuh.